together that we can just put all the things that we have on for reasons. Okay, so another part that's going to go underneath that reason column when we're dealing with segments is going to be our segment addition postulate. Segment addition postulate. So take a look back at 2.5 if you need to. What is a postulate? So I should hear some pages slipping. Go back to 2.5. We wrote it at the top. We didn't really leave space for it. Good. Things we know are true but can't prove. Okay, there are things we know are true that we can't prove. We can provide example after example after example. I can show you in real life how it works. And you can be like, yep, that works. But technically we can't prove it. There's no way to show why it works every time. It just does. It's something we know. Okay? It's like that color blue. We all just know blue is blue. Yep, exactly. All right, so we're going to do a segment here. A to J. And we're going to put a point in the middle that's in between, but we're not going to have it be the midpoint. So make it really obvious that it's not the middle. I'm going to put it really close to A. Not like really, really close, but closer to A. That way I know for sure it's not the midpoint. It's just somewhere in the middle. All right, Zayla, put your phone away, please. Thank you. All right, so as we look at this, we're going to take our two parts. So I have AM, and when I put that together with the other part, what's our other part? MJ. All together, what's that distance going to equal? AJ, yep. Perfect. And that's just what we just did in that warm-up. When we do that part plus a part, it's going to equal the whole. Okay, we've already done that. We did that back in chapter 1, which is awesome because now you're relearning it. So if you didn't do very good on the chapter 1 test, you can probably retake it and you're going to be like, dang, I know so much stuff now. It's great. Okay, but our segment addition postulate, where that's going to be one that we have to name now. Before we could just use it, we just were doing it. Now we're actually using it. All right, so you're going to get a glue in here. So you can go ahead and glue it in either on the left side here or the right side. You want to kind of glue it in as far to one side as you can so we have a lot of space for work off to the side. Okay? So go ahead, glue that in. Who are you texting? That's so important. Hi. It's very important today. I'm tired. Alright, so glue this in either way on the left or way on the right. Alright, so go ahead and glue that in either way left or way right. Can I make a pie? To go to the bathroom? Yes. I like to put it on the left and right on the right. If you're left-handed, you probably like to put it on the right and right on the left. Or if you just put it somewhere. Put it somewhere because it's important to have. If you put it right in the middle, you're just not going to have space to actually write your work. So that's going to be important that you put it somewhere where you can actually write. You have about 30 more seconds here to get that glued in. Get the caps back on your glue so it doesn't go crazy. And then this is the part where I'm going to start using colors. So if you wanted to take out that red, blue, green, you can. All right, so you are going to I don't know what we're going to do. We're going to read this problem. That's what we're going to do. Okay, so it says that if JL is congruent to KM, why is this crooked? If JL is congruent to KM, then JK, segment JK, is congruent to segment LM. So we're going to kind of color code this. We're going to think through it first before we actually write out our steps. We do know it's 6 steps in our proof. Okay, but we're going to start off with just kind of showing it. So I have KM. Nope, I have JL. I'm going to do that red. And that's jumping over this K. So I like to use those little brackets to show that we're jumping over. So JL is equal to KM. And again, we're jumping over that L, so I like to use those brackets so that I know it's that whole length. Okay, and then what we're trying to prove here is that JK is congruent to LM. So this JK part is congruent to this LM part. That's our goal, is to show that these two parts are the same. Okay, which we can do because when we look at both JL and KM, there's a part they have in common. What part do they both have? You look at JL and then KM. What's a part of it that they both have? Where's the overlap? Good. K to L. Thanks, Elizabeth. Okay, KL is that overlap. So if I know that these two are the same, if I look at that red spot and I take out the green, I'm left with JK. If I look at this part and I take out the green, I'm left with LM. And since they were the same, the parts that are left over, if I'm subtracting the same amount, should be the same also. Okay, so we're going to go ahead and start our proof. We're going to talk a little bit about how to set up a proof again. So remember, when we set up a proof, we're doing 2-column proofs. Okay, when you get a proof, there's a couple of things that you should be able to fill in without having to really do the math yet. Okay, there's no math currently that we are doing. We're just doing the setup. With the setup, what goes on the left side? Good, statements. And on the right side? Reason. Okay, now this one, it tells us there's 6 steps. We are going to write it kind of weird, so pay attention for a second here. We're going to go 1, 2, 3 right away. 1, 2, 3. And then because I worked out the proof, I know that we're going to skip a little bit of space. So we're going to skip 1 line and then do 4. Skip 1 line and then do 5, 6. So we know it's 6 steps. We're going to finish this in 6 steps. Okay, and then we can do the same thing on the reason side. Just label it the same way. Now, before we start, again, we're not really even doing much thinking. We're just setting up our proof. There's 3 lines or 3 parts that should be filled in before we even think about how we're doing this problem or what we're even doing with this problem. Thanks, Luca. You can leave it open. Okay, so as we look at this, what's going to be our first statement? What's the first thing that we have in our statement? Our hypothesis. JL is congruent to KM. What reason should always be our first reason usually? Given. Very rarely is our first reason not given. That will be like 1 out of every, 50 proofs. 2% of the time, maybe. Okay. And then the last thing that we can do before we fill any of our steps out, we can fill out, since we know it's 6 steps, we can know what we want to end with. We know the conclusion. What is our conclusion? What do we want to end with? JK is congruent to LM. We don't know why. We can't say like prove here or anything. We need to have an actual reason, but we are able to fill out those 3. So when you take the test on this, which is not next week but the week after, okay, when you get to a proof and you're panicking because you're like, gosh, I'm still not good at these ones, this is the part you should be able to fill in for sure without like any actual math, without knowing how to do anything. Those 3. All right, I'm going to color code as we go because it helps me think. So I have my JL is my red, and it's congruent to my blue, which is KM. All right, and we have to somehow connect that to number 2. So in step 1, we know they're congruent. What does congruent really mean? They're equal. So let's just write that. JL equals KM. And what do we call that when we switch from a congruent symbol to an equal symbol? Okay, when we looked at that yesterday, what tells us we can go from congruent to equals? Or back and forth. That's our definition of congruent. And are we really dealing with segments or angles? Segments. So that's our definition of congruent segments. So I'm just going to write def for definition and then congruent segments. Okay. Now, we're kind of at a standstill, but there's not much to do after this step. So now we need to look at the diagram and see if there's anything that we can tell from the diagram, which there is. When we look at the diagram, and I look at JL, is JL just simply JL? Nope, it's made out of 2 parts, right? What parts is JL made out of? How can I break JL up into 2 parts? Yep, J to K and K to L. Can I do the same thing with KM? Yeah, we can break it up. It's not the same segments, but we can break up KM. So what is KM going to be equal to? That would be K to L, good, and L to M, good. So if you ever get stuck in a proof, the next thing kind of look and see, can we break a segment apart into two parts? It's kind of a next thing. Okay, now what is that reason? We just talked about it today. What are we doing? Are we adding, subtracting, multiplying, dividing? Yeah, we're adding, and the parts that we're adding are segments. So that's what we just did today, is segment addition postulate. So I'm going to write it as segment, and then I'm just going to put add, segment, add, postulate. Oops. All right, so now, step 4. This is the part that's a little goofy. It's something that takes time to kind of see these patterns and see what's happening. It helps if some of this is filled out already. Like if it's fill in the blank, you can use it to kind of give yourself a hint what to do. What we're going to do is we're going to combine 2 and 3. We're going to put those together. 2 and 3 together into step 4. On number 2, it said JL was the same as KM. Instead of using JL, what did we say JL is the same as? JK and KL. So I'm going to write JK plus KL equals, and now same thing, instead of KM, what did we just say KM is the same as?
KL
Plus
LM.
LM. What do we call that when we switch something out? Substitution, good. Okay, now this is the part, again, where I'm going to be a little like, if I didn't know how to do a proof, I'd be like, how am I getting from this to this? Well, when I look at step 4 to step 6, I know I just want JK and I just want LM. I only want these. So what do I need to get rid of to only have JK and LM? KL. And with that KL, what are we doing with KL? We're adding it. So if I wanted to get rid of it, how would I undo adding? Subtracting. Which I can subtract, that's okay, as long as if I do it on one side, I have to do it on both. I have to do it on the other side. Okay, this is that green part. I forgot to color code that. Okay, so now the KLs are gone. What am I left with on this side, on the first side? Just JK equals LM. Okay, now remember we're kind of always lagging behind. We're looking at what we did. What did we just do? How did we go from 4 to 5? Yeah, that's our subtraction property. I'm just going to write subtraction. Be sure you don't write substitution. That's a common mistake when people are doing subtraction. They want to say substitution because they're so similar, but they're not. All right, and then from 5 to 6, what's changing when I look at just 5 to 6? Yeah, the equal sign is now going from equal to congruent, which is the same thing as what we started off this proof with. That's our definition of congruent segments. Anytime we're just switching the equal sign to congruent, that's our definition of congruent, and then we have to decide, are we dealing with segments or angles? And this one's segments. All right, take a breather. Shake it out. We got one more to do. I know it feels like a lot. That's because it is. That's why we don't have homework tonight. All right, I'm going to kind of draw that line so I know this one goes with the next part. I don't know. Okay, man. You guys are doing really good. Proofs are hard. They're a little confusing. It's really hard, and then on Monday, when you guys are doing these, I'm going to be making you do them on your own, and it's going to be hard. You're going to be like, what the heck is Miss Morrell making us do? Like, I have no idea what I'm doing. She's not helping us. I want to cry. It's okay. We're all just going to, Monday, let's all plan on crying during class, okay? We'll all do it together. All right, Samaya, put your phone away. All right, so as we take a look at this, we're going to start off with a 2-column proof. So we can go ahead and make those 2 columns. On the left side, I have statement, or I can make it plural and say statements. If I say statements, what am I going to say on the other side? Reasons. Either they're both plural or they're both singular. Doesn't matter which one you pick, just they have to match. Just have that parallelism. All right, before I even think about this problem, I'm not even going to read it. We're not going to decode it. I'm just going to start by writing down my first statement. What's my first statement going to be from this problem? Good. AC equals AB. What else can I write in that first step? Kaya, can you turn that down a little bit? Can you turn it down a little bit? It's really loud. Thanks. AB equals BX. And what else do I know? CY equals XD. Do I know AY equals BD? No, that's the grand finale. That's the aha. We're getting there. All right, and what is the reason that we wrote those 3 things down? It was given. We have not even looked at this problem yet. We have not figured out what any of these things mean. We just copied the given. Okay, you should always be able to do that part. Okay, so let's now decode it. Let's see what we're actually doing. Because now we have to actually think, right? Like we can't just go to step 2. So on this one, I'm going to start by color coding it, and I'm going to mark up our diagram a little bit. I know that AC is equal to, so I'm going to use the same colors here, AB. So AC is right here. And I know that that is equal to AB. Remember, we can show that they're the same by using those little tick marks. So if you weren't using colors, you would use those tick marks to show that they're the same. Okay, now normally I would switch colors for the next sentence, but the next sentence starts off with AB. What do we know about AB already? Yeah, that was equal to AC. I already used a color for AB, so I'm going to use the same color again for AB. But now I know AB is the same as BX. So what do we know about all 3 of those, really? They're all congruent. They're all the same. All right, the next part I'm given is CY is equal to XD. We didn't do either of those yet, so now I'm going to switch colors, because those aren't the same. So I have CY and XD. Okay, we can make those tick marks. And then at the end, what we're trying to show is that AY is the same as BD. Based on how we just colored it, so take a look at how we just colored it. Can we say that AY is the same as BD? How do you know, Tobin? Yeah, it's the same, right? The tops are the same and the bottoms are the same. So all together, should it be the same? Yeah. So that's what we have to tell our reader. Like, hey, we marked it up now, but in a proof, we're not showing our markings. We're writing it out in steps. Okay? Yep. Number 2. So the first thing that we marked were these red ones. And we started with saying AC was the same as AB, but then we noticed we used AB again. So when we're doing that, this is what we can think. Technically, this is not a math sentence. This is what we're thinking. AC is the same as AB, and AB is the same as BX. So this time, there's 2 things that are the same, but we haven't said they're the same yet. Which 2 are the same that weren't part of the given? AC all the way to that BX. Okay, since we could write it out as a long equal sign and a long we're traveling, that's going to be our transitive property. So we're going to say AC now is the same as BX. We haven't put those 2 together. We did these 2, AC, AB. We did these 2, AB, BX. Now we're going to do AC, BX. And that's that travel we're skipping over. It's kind of like a long switch rather than a short switch. So when it's a long switch like that, that's our transitive property. Okay, so step 3. I'm going to color code that for a second. Sorry. Getting too excited. Moving on too fast. Proofs are just exciting things, you know? Kayla was like, what the heck is she talking about? All right, number 3. Now at this point, there's no other connections there. We just did the CY and the XD. So we need to start thinking about where are we going. Eventually, we're going to AY. Is there anything from this diagram that I can state about AY? There is. I can write AY as how many parts?
3.
What?
2.
2 parts. 3 points, right? Okay, so what's that first part? What's the first segment that AY is made out of? AC. Plus, what's the second part? CY. So my whole AY is AC plus CY. Can I do the same thing to the other part that we're trying to compare it to, BD? Yes. Okay, so take a second here. Try to write out your equation for BD. What is BD equal to? Don't say it. Take a second. Just write it. If you're somebody who you don't want to write it and then erase it if you have it wrong, just think of it. What is BD going to be the same as? What would we start with? We would go B to X and then X to D. Okay, what do we call that step? What's our reason for that one? what are we doing in that step? We're writing what kind of problems? Yeah, we're writing adding problems is what I would have said. But Elizabeth just knows it so much already. Nice job. What are we adding? Segments. So that's our segment addition postulate. Kinda, dear. What do you need, dude? You really have to come in class and get aqua for? Oh. I've never had an emergency that required aqua for.
I'll put it back.
Or she'll give it to you later. Okay, so now at this point, this part is a part that like I would not think of, especially if I was learning proofs. This is a part that like as you go, you have to kind of learn. It's very weird. Okay, it's not weird, but it is weird. So I'm going to do this as like I'm going to do a little dash across here. This is our work. We're going to show a little bit of work here. If I was publishing this in a book, I wouldn't show this work. It wouldn't be professional for me to show kind of what am I thinking. I would only want to show what is my endings. What are my findings? So for our work here, we're going to start back to number 2. I'm going to rewrite number 2 here. AC equals BX. Generally speaking, in a proof, we don't want to repeat what we've already said, so that's why this is the work. Now, in order to get to AY, what do I need to put with that AC to get AY? What needed to be put together with AC? CY. So I want to add that here. I want to add CY. And if I do that, that's okay, as long as if I do it to one side, I have to do it to the other side, yeah. Okay, and then this is where I'm going to end my work. That's the part that we were thinking. So now for step 4, I'm going to write that out in an actual equation. So we're going to have AC plus CY equals BX plus CY. Okay, what do we call that? What did we do to both sides? Add. So that's just our addition property. Now for step number 5 and 6, we have 2 more steps. You guys are doing great. Okay, we know AC and CY. Does that make AC AY? Mm-hmm. Does BX and CY, is that what BD is made out of? No. But what do I know CY is the same as? XD. So I'm going to switch in number 5 here. I'm going to just take the CY and switch it for what it's equal to. What was CY equal to? XD. I'm going to copy everything else down the exact same way. AC plus CY equals BX plus XD. It's kind of all squished. Okay, I know that these were the same. It was green for green, so we can switch it. That's a quick switch. We didn't have to write it out like we did up here with that transitive property where we were like going over something. We just flipped it for something it was equal to. So what do we call that when we switch it for something that it's equal to? Substitution. Okay, for our last step now, step 6, I can look at this and I know ACCY. What was another name, or as we look at our drawing, When you go from A to C and then C to Y, where are we really traveling from? A to Y. And we said it right here in step 3. We said AC and CY is really equal to AY. And now, what's BX and XD really together? BD. And that's what we were trying to prove, that AY is the same as BD. What do we call that? Again, we're taking something and we're just switching it out for something it's equal to. Again, it's substitution. It's okay to have substitute. Some of these proofs, they have substitution listed as like 5 different steps. We use substitution a lot. When in doubt, substitution. All right. Woo! Good job. You guys crushed it. That was a lot of notes today. There is no homework, extra homework today. We do have about 7 minutes.